So now we're going to stop talking about indicators and we're going to go to something entirely different. So we're going to talk about acid-base pairs. So whenever you have an acid and a base and they react with each other, because that happens a lot where you have an acid reacting with a base, the acid actually turns into a base. So we're going to write down acids turn into bases, and the base that they turn into is called the conjugate base. So acids turn into bases when they donate, so that's just a fancy way of saying give away, so they donate a proton, and when I say proton, that actually means H plus. Hydrogen ion, H plus, is actually just a proton, because hydrogen is just a proton and an electron, so when it loses the electron, it's just a proton. So we're going to make a list of some acids and their conjugate bases. So here's some acids. And then these are the bases they turn into when they lose the hydrogen ion. That's what acids do. They just give away their hydrogen ion when they react. So an acid like HF, it's hydrofluoric acid, it's actually very dangerous. When it loses that H plus, it turns into F minus. F minus is a base, and it's negative because it lost an H plus. Okay, similar acid, HBr, loses an H plus, turns into Br minus. So there's the acid, there's its conjugate base. Nitric acid, HNO3, when it loses an H, it turns into NO3 minus. Now, sometimes we have an acid that's already charged to begin with. So let's say we have something like HSO4 minus. When it gives away an H, it's going to become SO4 2 minus. So that's its conjugate base. Sometimes you have something with more than one hydrogen, like H2SO4. Okay, the conjugate base of H2SO4 is what happens when it loses just one H, not both of them. So the conjugate base of H2SO4 is HSO4. So it's kind of weird. You'll notice HSO4 minus can be a base and an acid. So HSO4 is the conjugate base of H2SO4. And there's a bunch of others we could write down, but that's good for now. And the same thing happens with bases. Bases actually turn into acids when they react with acids. So we're going to actually go over onto the other page. So we're going to go over onto page 108. Okay, so bases turn into acids, and the specific name, oh, you guys can't see what I'm writing, just a second. Okay, bases turn into acids, which is the conjugate acid, when they accept a proton, which is just H plus again. So we're going to make another table with some bases and their conjugate acids. All right, so common base is ammonia, NH3. Bases, they gain hydrogen. They're good at taking hydrogen. And so they become positive when they turn into conjugate acids. So NH3 turns into NH4 plus. H2O can be a base. It can also be an acid. It can be both. If it accepts an H, it turns into H3O plus. CO3 2 minus, carbonate ion, can accept an H, and then it becomes a little bit less negative because it accepts a positive H. Again, like I said, some things can be acids and bases. You'll notice HSO4 minus was over there on the acid list, but it's also, it can act as a base, and if it acts as a base, it's going to become H2SO4. So it is acting as a base to become a conjugate acid. So when I say it's acting as a base, I mean it's gaining an H plus and turning into an acid. Okay, I know this is kind of hard to wrap your head around, but if you just take it really slow and really think through it, you guys can figure this out. Okay, a couple other things you need to be able to do with this. You need to be able to look at a reaction and figure out what is the acid, and what is the base, and what is the conjugate acid, and what is the conjugate base. So let me write out an equation and we'll talk about this. So let's say we have HC2H3O2 plus H2O forming C2H3O2 minus plus H3O plus. Okay, so a couple of things. The acid and the base are always going to be on the reactant side. So this is either the acid or the base, and this one's either the acid or the base. And then the conjugate acid and base will always be on the product side. And you'll always have one of each. You'll have an acid and a base and a conjugate acid and a conjugate base. So you'll always have one of each of those four things. You just have to figure out which one is which. So you have to look at what happens to the reactants during the equation. So you'll notice this guy, this is actually acetic acid, it loses an H, right? Do you see how it has HC2H3O2 and now it doesn't have that H? So since it's losing an H, we know it's an acid because acids lose or donate H+. So that's the acid. And then if we look at H2O, it's probably gaining an H. And it is. It's gaining an H to become H3O+. So whichever one loses the H is the acid. Whichever one gains the H is the base. Okay, and then remember the acid turns into the conjugate base. So I'm going to label this one CB. That's the conjugate base. The base turns into the conjugate acid. So I'm going to label that CA. Okay, let's do just one more because I know this is a bit tricky. You guys can do this. Okay. We're going to have CH3NH2 plus HClO making ClO minus plus CH3NH3 plus. Okay, so let's see, just maybe the first thing you want to do is look for which one of these is losing the H, because whichever one that is, it's the acid. So this one is getting an H. It's going from H2 to H3. So that's not the acid. This one is losing an H. So it's the acid, and we know the acid turns into the conjugate base. It's always that way. Acid turns into base. So that means this must be the base, and it's turning into the conjugate acid. And we can verify that by seeing that it's gaining an H. Okay? So again, if you need help with this, let me know. But that's how conjugate acids and bases work. Remember, the acid always has to give away an H, and the base always has to accept just one H. Acid gives away one H, base accepts one H. If anything else is happening, it's not a conjugate acid-base reaction.